All right then. Good morning, everybody, and thank you for joining us today. We have a very exciting webinar to look forward to, discussing the pandemic learnings on viruses and air cleaning and the learnings we can make. My name is Sarah, and I am here to guide you through this hour. Together with me, I have three experts. I'm not going to do this alone. First of all, we have Niklas Arnberg, Professor of Virology at Umeå University, Sweden. We also have Håkan Eriksson, who is an air cleaning expert at QleanAir Scandinavia, and Johan Billing, Product Manager at QleanAir Scandinavia. Why don't you just unmute yourself and say hi to the audience, and maybe a little bit about what you do.
So, hello everyone. Very happy to be here and be part of this exciting event organized by QleanAir. So my name is Niklas Arnberg then, and as Sarah said, I'm working as a professor of virology at Umeå University in northern Sweden, where I have been for some 30 years now, working mainly with different types of adenoviruses and some other viruses also. Very, very exciting work, and especially these days. I also have a task as the chairman for the board of the Pandemic Foundation, or the Pandemifonden, which we will get back to, I think, a little bit later on. Thank you.
Yeah, good morning. My name is Håkan Eriksson. I'm an air cleaning expert at QleanAir Scandinavia and been hunting small particles for over 15 years now. So we are very well prepared for this seminar today.
Hello, everyone. My name is Johan Billing. I work as product manager for our freestanding air cleaners, and that means we in this area help our clients in reducing airborne contaminants in the air that they're working in.
Great, thank you. Feels very good to have this panel of experts with us today, and this is the agenda we will work through over these hours. We have a lot of things to go through. We'll start by discussing the current corona situation with our virologist in the room, Niklas. We will also discuss clean air solutions a little bit more deep with the experts there. We will discuss viruses and air cleaning, the learnings we have so far, what is the new normal going forward, and we will summarize the learnings and of course also invite you in the audience to ask questions. Let's move forward then to the fun stuff. We will start with you, Niklas, as you have deep knowledge about viruses and virus research. And I guess you also have one of the most interesting jobs at the moment. How would you describe the current corona situation we are in right now?
Yeah, thank you, Sarah. Yeah, this job is really interesting, always interesting being a researcher, but perhaps particularly interesting these days. And yeah, so when it comes to the current situation, we still have a problem on a global level. As we can see on the next slide, we have lots of daily new cases all over the world, more or less at least. I think we have almost 800,000 or 750,000 new cases being registered every day all over the world. And there is probably an underestimation. There's probably a whole lot more cases that are actually not registered. And a lot of people are dying. So we're suffering still, but there is light. So we will come back to that also. Well, I think Sweden has some problems, other countries also. I think that the country that now drives the pandemic is India, which has something like 400,000 new cases every year. During the last few days, I think that I have seen what can be a peak. So the numbers are hopefully not actually increasing even more in India these days, but they still struggle.
And as a virologist, if you now, when you have time to look back on the pandemic outbreak over a little bit over a year ago, would you say that everything come as a surprise for you, or was this something you had forecast?
Yeah, I think both yes and no. It was impossible, I would say, to everyone, to foresee what has happened right now, what kind of virus, a coronavirus that caused this pandemic. We didn't know that. We didn't know how problematic it would be, how long time it would last, and so on. But one can say that we did knew that something would happen. We knew that for sure, and we have been talking about this a little bit also. But we didn't know that it would be a coronavirus. I think most of us thought that it would be an influenza virus, because that is the kind of virus that has caused the pandemics during the last 100 years, I would say. But we weren't really surprised, and to some extent. And yeah, I can say stop there.
Yeah, but you say you weren't surprised. Why is that?
Because exactly. So this is because the WHO, they have announced what is called a global emergency no less than 6 times during the last 12 years. All of these outbreaks have been caused by viruses, and 2 of them have developed into pandemics. So we had the swine flu causing a pandemic about 10 years ago, and now we have the SARS coronavirus 2 that has caused this pandemic. So we knew that something would happen actually. So one can say that. And WHO, they also knew this. So they have focused on virus-caused infections for quite some time and said that this is important, this is a challenge, and other people have also mentioned it. So we knew that something would happen.
But I guess the follow-up question then is, if like the virologists already knew about this, why wasn't the world better prepared, would you say?
Yeah, so here I think that we will have to be a little bit self-critical also. We have tried to talk about this for some extent also, but I think that as researchers, we also don't want to be called alarmists, for example, and shout that the wolf is coming. We're also a little bit afraid that sometimes we can be accused of talking about this in our own interest because we need grants. Now I think the situation is different. I think that we actually can talk about these situations openly, since they are so problematic. And that is something good, I think.
All right. Interesting. You also have this image. What is this? And this
that's right. Yeah. So WHO have announced global emergency 6 times during the last 12 years. All of them has been caused by viruses. And because of this, WHO, they have produced something that is called a blueprint priority diseases. So this is a list of infectious diseases that WHO says that we need to do more research about. And that is because these diseases, they are contagious, they are dangerous, and we lack treatments, we lack antiviral drugs. And what is strikingly here is that all infectious diseases on this list, they are caused by different types of viruses, as you can see here, many different viruses. And one of them is called disease X. And this represents the knowledge that we will also be exposed to unknown viruses in future. Unknown pathogens, could be bacteria also, but we have to prepare for this also. So this is something that they call disease X, and something that we need to prepare against to whatever the extent that we can.
Interesting and quite dangerous. We will talk a little bit more about the future later on in this hour. If I head over to you, the air cleaning experts in the room, Johan and Håkan, I know you work with many different companies, organizations in different industries. And with your knowledge, and I know you've been in contact with them over the year, with your everyday knowledge, what would you say, how did the coronavirus impact your clients?
Well, the main difference is that we've seen a change in awareness. There's an increased awareness of air quality indoors mainly, even outdoors, but mainly indoors. We also seen a change that where companies earlier were more eager to protect their products or their processes, it's much more focus on people right now. We also seen a big change in the demand of filter quality. Requests are to a very large extent on high quality so-called HEPA filters, or even HEPA 14 filters, the highest HEPA quality. We've seen 2 waves. First wave was from the healthcare sector. Very, very clear. We had a lot of hospitals contacting us, and they needed to increase their possibility to treat people in rooms where they normally don't treat people with infections. And now, secondly, we see that we got a lot of requests from schools, from offices, and from businesses doing continuity planning. How can we go back to something? We need to be at our workplace. How can we go back to that? So that's what we have seen.
So these environments where more people are meeting and come and go.
This is shared spaces where people need to be or need to meet. Everybody cannot sit at home and do their work from home. There's a lot of people that has to be on their workplace, like all production, food production. They really need to be at the site. It's a little bit difficult to produce food from home.
Yeah, for sure. You mentioned it a little bit, but it's interesting to hear you talk about the shift in awareness. But can you see any difference between the sectors you work with every day?
Yeah, the big difference is that they are to a much larger extent interested in protecting people, to be sure that not only the products you are, for example, we've saw in the beginning a lot of outbreaks in food industry, especially in meat industry. And we already had a lot of customers in the food production segment doing air cleaning, but until now, the air cleaning has been to protect mainly the products, to have a good product quality. Now, all of a sudden, focus was changed. So a lot of them starting to realize that if the people are not here, they cannot produce anything. So we need to protect products and people in this case. So this has been a really notable change of focus from our customers.
Interesting. And Johan, as you also work with this every day, how have you been adapting to the situation as the awareness is increasing?
Yeah, we have a prior experience in building tailor-made solution for virus filtration for hospital infection and the isolation wards. So dealing with viruses, we have knowledge with prior to this, and we also have a lot of experience with dealing with particle filtration. So based on these two knowledges, we had a good foundation to stand on when building or constructing new solutions for our clients. And we did this in tight collaboration with the Karolinska University Hospital to get insight into what kind of shared spaces we need to deal with and the specific needs there, and also taking into account other areas outside hospitals, such as offices.
Interesting. And to summarize, as I know you've been in dialogue with these different kind of organizations, small and big, different sectors, what would you say is the key success factors to kind of adapt for you as QleanAir, adapt to the new situation?
Yeah, I mean, a tight dialogue with the clients is extremely important to understand their specific needs and to be able to fulfill them with a good solution.
Interesting. Yeah, we're going to talk a little bit more later on different kinds of shared spaces, since there's so many and they have different needs, of course. But first of all, we're going to dig a little bit deeper into viruses and air cleaning. Why would you say, Niklas, why did the coronavirus cause such damage?
Thank you, Sara. So I think this is a very good question. I think that one reason to this is because we are now almost 8 billion people in the world, and we travel more than we have ever done before. And I think that we also empowerish, or in Swedish utarmar, the biological diversity in a way that has never happened before on this planet. So altogether, this means that we are also more exposed to different pathogens, including viruses, and we are more vulnerable. So therefore, I think it's not a surprise that WHO has announced a global emergency 6 times during the last 12 years, and all of them have been caused by viruses. I also think that it matters that when it comes to, for example, bacteria, we have antibiotics. Antibiotics works, and it prevents transmission between of bacteria between people also. This is something very good, but we don't have the other thing, the thing for viruses, that is antiviral drugs. So we only have antiviral drugs that break transmission against a few, very few viruses. But if we have had antiviral drugs against this virus also, I think the situation would have been completely different. So this is something that we need to do more work on, more research.
And you earlier showed us this image of different particles, but is all viruses bad? How worried you would be?
Yeah, well, some viruses are actually good. Without viruses, we wouldn't have mammals on Earth. I will not dwell into this actually, but some viruses are actually good. They can contribute. But most viruses are really bad, I would say. Most viruses cause problems, and we have not knowledge enough about all these viruses, and we lack antiviral drugs, we lack vaccines, we don't have testing capacity, for example. So we need to do much more research into this.
Interesting. Another thing that's been discussed very much during the year is the droplet versus aerosol transmission. And what is the coronavirus really? Would you mind maybe elaborate a little bit about this and clarify what is the difference, Niklas?
Yeah, thank you. So this has been heavily discussed here in Sweden, probably in many other countries also. And first of all, one can start talking about symptomatic and asymptomatic disease. And the symptomatic disease and transmission takes place when we cough or sneeze. That is the symptomatic disease. And then we have something that is called pre-symptomatic or asymptomatic disease. And that is when we not cough or we don't sneeze, but we still exhale viruses. And the symptomatic disease and the droplets that we sneeze or cough out, they are quite large and quite heavy. So they fall down quite rapidly within 1 meter or 2 meters. So this is the distance we need to have in order to protect ourselves from the symptomatic or droplet transmission. But what is difficult to protect us against them is the airborne or aerosol transmission that takes place. Smaller particles that are not as heavy, they can be transported much further away in a room, in a distance, and they will stay in air for a much longer time also. So I think this is the main reason to why we now have so much problems to control this pandemic. And that is that a substantial part of the transmission that takes place is actually airborne or aerosol driven. So this is a challenge.
Yeah. So to clarify, you say it's mostly airborne.
I wouldn't say that it is mostly airborne, but that's definitely substantially airborne. So the droplet transmission is there. We don't know what dominates, but I think that what contributes to why we have this difficult situation is that a substantial part of the transmission is also airborne.
All right. And would you say, as the discussion was a little bit different a year ago, would you say that we maybe underestimated the risk of this virus?
Yes, I would say so. Early on during the pandemic, we only talked about the droplet transmission. We also talked about contact transmission. So we talked about hygiene, hand hygiene, and using alcohol to clean our hands and so on. But that seems to be a very limited route of transmission. So I think it's the droplet transmission and the aerosol transmission that dominates. The relative transmission between these two, we don't know about. And it may also differ from time to time, situation to situation, and room to room, and so on, person to person.
Yeah. All right. Well, how would you say, how easily do viruses spread in shared spaces? I know we have this list. Is this everything you need to think about?
Yeah. So sometimes one gets the question, what is the risk for transmission? And one would like to give a number on this, but it's impossible, I would say, because it depends on many different factors. For example, is it that the person is heavily infected and produces lots of viruses? Is the person that you are in contact with in a room, for example, is this person a super spreader or not? That is impossible to say. Transmission also depends on climate. We know that this virus, as other seasonal coronaviruses, they transmit much, much more easy during winter when it's cold outside and when the relative humidity indoor is drier. And this means that the particles becomes smaller and a little bit less heavy, which means that they can transport more easily and more far away at a distance. It's also so that our mucosa becomes a little bit thinner during winter, which means that we are more susceptible to virus-caused infections. Some people think that face masks also contribute. I think that face masks can make a difference. We use face masks because we don't have better tools, I would say. They can make some difference at some points in some situations. And then, of course, there are also many other different factors that contribute also. What kind of room are you in? What is the space? How many people is it in this room? And of course, the airflow and ventilation makes a difference also. Is it an old building with an old and less efficient ventilation system, for example? So there are many factors that contribute and explain the risk for transmission. It is a complex material.
Johan, I know that you also work with measuring the level of air quality on a daily basis. How do you do that?
Yeah, well, it's rather complex with many factors to take into account. Of course, the volume of the room, the number of people in the room, the activity being conducted in the room, temperature and humidity, of course, and the mode of ventilation. Are you using window ventilation or are you using a mechanical ventilation system? And if that is the case, what amount of air are you providing to the room every hour, as well as is there any air cleaning solution installed in the room? And when it comes to the difference between ventilation and air cleaning in the room, I would say that the primary task of the ventilation system is to provide oxygen and remove carbon dioxide by dilution. It is most often not designed to deal with severe concentrations of contaminants such as virus being generated inside the building. And this is where air cleaners come into play, because they can, through recirculating the air inside the rooms, reduce those concentration levels and work then as a complement to the ventilation system.
Thank you. But as this seemed to be such a hard task to measure and to calculate the risk and the air quality level in a room, Håkan, how does air cleaners really work?
Well, there's a lot, as Johan said, there's a lot of factors when you calculate what's needed in a room. But one thing that's very clear, that an air cleaner is working with the air inside and whatever is produced inside the room. And as Johan said, ventilation provides you with fresh air and make sure that like CO2 levels or CO levels are not too high. But whatever is produced inside a room, ventilation is not strong enough to help you with. We work with mechanical filters, mechanical filtration. That means a high quality filter media that captures the particles. And you need a high volume, a high airflow from the air cleaner. And what you do basically is that the air cleaner sucks in the air into, you see a picture of a filter media here. And then all the particles, I will say and all filters are classified to European standard. And you should always look for a filter classified by this European standard. It's called EN 1822. If the filter is not classified by this, well, then you might start to wonder why it's not. And you need a lot of filter area, for example. Like if you take a big basic mechanical filter, it should always have a label stating what kind of filter am I looking at? What kind of quality do I have? And if it's a HEPA filter, if the producer says, well, this is a HEPA filter, then you should find a test protocol of this filter also attached, because every single HEPA filter of 13 and 14 quality is tested. According to the standard, should be tested.
Yeah.
If it doesn't have a test protocol, it's not a HEPA filter.
Okay, so that's a quality standard to look out for.
Yeah, definitely.
Yeah.
And then the next thing that you need to do, this looks a little bit bulky, but you need a lot of filter media because you need to move around a lot of volume of air. We have filters where the surface of the filter, for example, I'll show you, this is a little bit difficult because this is another big HEPA filter, and this filter actually has the size of the filter. And if you compare it to the filter media inside, the filter media is 30 times bigger the size of this monster filter. So you need a lot of filter media with high quality filter, and that's the way to reduce the particles that you release from your unit.
Yeah, and if you are like me, a beginner on air cleaning solutions and what to get and where to go, where to find it, what should you do to start?
I mean, first of all, there's two. We work with professional. We sell to big companies, big organizations for home cleaning, or if you look for something, Sarah, to your bedroom or to your apartment, well, there are many quality air cleaners to be used at your own home. But when you come to a little bit larger units and larger solutions, I would say you need to talk to somebody that knows your business, that can go out, do a measurement, and also take all your facility, your activity in consideration, and then create a solution for you. This would be my take on this.
Thank you. Moving on, this is an illustration from you, a cleaner on air circulation. Would you like to elaborate on this one, Johan?
Yeah, this is an example of how an air cleaner can work in a room. And if we look at the left picture, it's a typical scenario from a classroom in Central Europe. Typically, you don't have a mechanical ventilation system in these type of rooms. You rather work with window ventilation to provide fresh air. And on the right-hand side of the room, you see the windows. In the center, you see the desks where the pupils are at, and on the left-hand side, you see two air cleaners standing. So one efficient way of reducing the contaminants in these type of rooms we have seen is to follow the natural flow of the air inside these type of rooms. So we enhance this type of flow in the room. That means that the air is heated up by the pupils and the heaters in the room, and that means from the people the air will rise to the ceiling, and when this air under the ceiling reaches the windows, it will be cooled down and then move down to the floors again. So it's a circulating movement inside the room. So what the air cleaner does here is that it sucks in the air at floor level and blows it out at the top towards the ceiling again to enhance this movement of air going around in the room. And the reason we want to do this here is that we don't want to create a draft for the pupils or students in the room, and you don't want to risk to create any jet streams where air is traveling from one person to the next person and thereby risk spreading a virus from one person to the next just by this air movement.
I see. I think I see. But if you would like just to summarize, why is it so important with having an air circulation in the room?
Yeah, what you want to have is a reduction of the contaminants in the room. And if you reduce the amount of virus in the room, you also lower the risk of being infected. The concentration being one of the factors if you will be infected. Of course, there are many more, but that is one vital part.
Great.
And as I said, you don't want this to happen with a jet stream that transfer air exhaled by a person that is infected to go directly into the face of the next one.
Yeah. Thank you. We'll go on and discuss the new normal. And I say the new normal all the time, but I know that you don't really agree, Niklas. Is it possible to talk about a new normal, or when will the pandemic be over?
There will be something like a new normal. I think that we have learned from this, and we will, for example, travel much less than we have done before. I think that we will have more digital meetings. We will work from home more than we have done before. These are some things that will be different. But I also think that we are social creature. All of us humans, we want to meet other people. We want to have a beer, have some food at a restaurant, for example, meet people there. We would like to go to cinema. We would like to go to theater. We would like to go to concerts. We would like to see sports, football, ice hockey, handball, and so on. We need to go to the hospital sometimes. We need to, for example, go and buy some groceries and stuff like that. So there will be risks for transmission of different pathogens in future also, and we need to relate to this. We can we may use face masks to a little bit higher extent than we have done previously. We know that in Asia, for example, they use face masks all the time, not necessarily to protect against pathogens, but to protect against poor air, for example. But some things will be different, and some things will be the same in our part of the world also. So a little bit of new normal also.
A little bit of new normal. Great. Yeah. How is it possible to plan 3 or 5 years forward in the future then?
Well, if this pandemic would have been caused by an influenza virus, then I think it would have been easier to plan, because we know from previous pandemics, and because this kind of virus, the flu virus, mutates much faster than, for example, coronavirus. And then we also know that the new viruses, pandemic flu viruses, they mutate and adapt and change rapidly to become so-called seasonal flu viruses within just 1 or 2 years. But now with this virus, the coronavirus, this is a virus that mutates slower than all other RNA viruses. And this is both good and bad. The good thing is that there is actually a chance that the new type of vaccines, single gene vaccines that we can call them, they can actually be good enough to take at least some of the variants. We can also update the vaccine so that they will take new variants, but we don't know. So this is the good thing. But the bad thing is that it may take many years before or until this virus have adapted and become a new seasonal coronavirus. So this makes it all in all a little bit difficult to plan for.
Yeah. And Håkan, you described in the beginning your insights from the year talking with different clients and sectors. How would you describe, what are the spaces and environments where you see increased demand?
Well, as a private person and a private citizen, restaurants and bars, it's been very, from my point of view, wise from most governments that they've closed down or made restrictions on restaurants and bars. Not that you sit together and eat, but there are a couple of factors. It's getting louder and louder. People are talking louder and louder, and under the not very seldom, the effect of alcohol makes you talk even louder. And then you have a possibility to spread quite a lot of virus. You also sit at the same place for a long time, or stay at the same place for a long time. And the later it gets, the more close people are talking to each other, and you have a big risk there. I also see a risk at arenas. We've been discussing with Niklas also, since we are from Sweden, and we like our ice hockey. We have had a lot of ice hockey teams, the players that have been affected. And this is a combination on the temperature in the indoor arena. There's a combination that there's people breathing heavily. They are changing either in locker rooms where they sit really tight together, or as ice hockey, you sit on the side and waiting for your turn on the ice. Troublesome that we've been discussing also, that all these teams, these football teams, we saw my favorite team from Sweden, Hammarby, the whole team was affected. 16 players and 5 leaders was affected after a game. And this is people that are overwatched or tested constantly. They have a team of doctors around them, and still, as Niklas said in the beginning, they are asymptomatic most likely, and there's no professional football player or athlete whatsoever that sits together with other athletes and coughs and sneezes. That's unheard of. And you don't compete when you're not feeling good. So this is a place, and also as a spectator, as a big football fan, for example, I'm not really keen on standing really packed together with all my friends cheering my team and shouting very high. That's for me, for the moment, a no-go. I wouldn't go there. Then we have places where the choice is more difficult, schools, and it's difficult to have kids separated and ask them to stay away. So this is places where we still need to meet, we need to be there, and we need to provide solutions. Either if it's, and as Johan said before, we need to lower the concentration of possible virus. And you can do that by opening windows, having air cleaners, increase your ventilation, whatever means you have, or a combination of a lot of means.
Yeah, and like you said earlier today, some organizations cannot just shut down and work from home.
We see a lot of places where fire brigade, police, hospitals, a lot of functions in society where you cannot work from home. You need to be there, and they're also, most of them are critical. So you need to stay very focused, and there you need some help, and you need to plan a lot how to avoid disruptions or that a lot of people or a lot of your staff getting sick, because these are the functions that's, you can't run a power plant from home. It's a little bit difficult.
Yeah, for sure. As we have quite many listening in today, and I can imagine from different companies, organizations, and sectors, Johan, what would you say to them if they want to protect their employees and people?
Yeah, well, first of all, you need to make a risk assessment of your spaces and operation. And you will soon find that some places are more critical than others, and there you will find a higher risk of infection spread. And you also need to look at routines and action plans to minimize simultaneous number of people in those shared spaces. And you need to assess the method and the amount of ventilation that is provided to those spaces, as well as look at the possibility or need for installing a complementary air cleaning solution in those spaces in order to reduce risk, so to say.
And I know you have these concrete steps.
Yeah, let's see, my picture went out. Yeah, you need to assess the situation you have, make an analysis of that one. You need to keep the distance between people. If in an organizational way, so to say, you need to make sure you ventilate properly. You need to look at installing potentially an air cleaning solution in areas where you have a higher risk in order to reduce contaminants. And you need to plan long term. This is not a situation that is over in June, so to say. This is a situation we need to plan for much longer.
Yeah.
And I know we have a document where we have elaborated on these five steps, so to say, and if you let us know in the chat, we're happy to share that with you. But also make sure that you make contact with the air cleaning professional, such as QleanAir, to help you in these steps and find a viable, high quality solution that will work long term for you.
Great, thank you. Yeah, like Niklas said before, it's hard to plan even 3 years forward. So make sure to set a good strategy and take advice from the right person. Just want to go very quick through the future. Niklas, what would you say is the very next step in terms of gaining more knowledge about this?
Oh, thank you, Sarah. So the next step, the main question, the million-dollar question now, I think, is will the vaccines work against new variants? The vaccine work against the original variant and probably against some variants, but the question is, will they work against all variants? We don't know about that. So that will be a key question to see. We know also that this is a seasonal virus. It will decrease in transmission during the summer, and then we will see what happens late autumn, next winter on the northern hemisphere. I think this is the key question that we would like to see. What will happen then? Can WHO declare the pandemic to be over? That will be hard to see.
Interesting. So we will wait and see and do more research, and also we need to gain more knowledge about this.
That's right.
Summarize, yeah. Thank you. I will jump to the last question for you, Johan. What learnings do you hope that organizations will take forward in order to protect people and secure a healthy indoor air quality?
Yeah, well, I hope that they bring with them the importance of investing in clean air in shared spaces, because it makes such a difference for people's health.
Great, thank you. Do you want to say something, a last word, Håkan?
What we've seen, what's the next step, what will help? Niklas said that we don't know for the vaccine. What we do know is that air cleaners work. They will work even with the vaccine or without the vaccine. But what we see, and what I hope really that people, organizations, and companies take in consideration is that there is a change now from air cleaning and long-term effects. You have a business, it's dirty for some reason, you produce something inside, you invest in air cleaners, and it's a long-term effect. Now, with the pandemic we've had, you have immediate consequences. A whole department or a whole team or a whole company has to shut down because there's a wild spread. And this, I really hope that companies, countries, regions plan in a better way for, because it's been striking us very, very hard to a lot of places.
I will jump right through it since we have so many. We have a question here. There's numerous kinds of filter out there on the market based on different technologies, and there goes for enormous prices. How would I know which air cleaner to buy for our hotel lobbies?
Let's see. I would go for, our recommendation is to work with mechanical filtration. You can also, now we're talking about viruses, then there's gases and other stuff. But if we stay at particle filtration here, first of all, it's tricky. Because as Niklas said in the beginning, this is most likely an aerosol short range or a little bit longer range transmission. The particle where the virus is inside is changing size since it's fluid normally. So depending on humidity, depending on temperature, depending on time, it will change size. If you go for a HEPA filter, especially HEPA 13 or the highest quality HEPA 14 as we are using, you know that you are filtrating and catching these up to an extreme high amount of percentage. It's always a percentage numbers game. Yeah. I would suggest that you use mechanical filtration, high airflow, and you need somebody to help you to work with where to place the air cleaner so you get the best efficiency in the room. And there is a reason why there is a European standard for filters. And then there's a lot of technologies, other technologies that are not standardized, or different companies have their own technology. But I would go for a tested, standard, proven quality filter and filtration system for definitely for a hotel lobby.
Thank you. And yeah, it was actually a follow-up question. What is a reasonable price for a 100 square meter lobby? But I guess that is hard to say.
It's impossible to say, like in a seminar like this. You need to have a look at it. How many entrances? How many people are there? How high is it? What's the volume of the room? So there's so many things to take in consideration. It's difficult. You need to have a look at it.
Yeah. So Stephanie, contact QleanAir for help with measurement and to look into the numbers. Another question here. I have thought about how much can filters help when the coronavirus can be down to 0.05 to 0.14 micrometer, and the typical sterile filter used to clean air is down to 0.2 micrometers. It was a lot of numbers. But...
a lot of numbers, yeah. Filtration technology and the physical laws around it, it's actually doesn't work the way the smaller particle, the harder to filtrate. It actually doesn't work that way, because smaller particles behave in a positive way for a filter. They're very they move very randomly, and they normally also cluster, so it's actually easier to catch them. So large particles and small particles, a HEPA 14 filter filtrate almost 100% of them. The tricky part is something called most penetrating particle size. And here a HEPA 14, for example, is proven and tested to filtrate 99.995% of all the particles. Can you go higher? Yeah, but then airflow is starting to get critical because the filter media is starting to get so dense. So it doesn't mean that a smaller particle is harder to catch. It's actually a little bit easier to catch.
Interesting. Yeah, I see you raise your hand, Niklas, and I know that I'm thinking about your image that you showed in the beginning with the image of different particles. So that's not the case when it comes to air.
Yeah, exactly. And I would just like to say also that these kind of filters are the same filters that we use in our safety benches, where we work with different types of viruses, biosafety laboratory 2 and 3 classified viruses that are these small. So these are good filters to clean air from these kind of very small viruses.
Great. I know you've been mentioning there's different techniques for cleaning air, and different companies do different ways. You do the mechanical way. We have a question from the audience. How is the virus protection resulting from air filters compared to ionization products?
Yeah, okay. I can try to take this one. Yeah, we have chosen to go with a technique that only removes things from the air instead of adding things to the air. This is because what you add, you cannot to 100% control. That means you cannot control chain reactions taking place in the room, and since you can't control the conditions of the room, you're not in 100% control. Also, these type of techniques, they cannot separate between good and bad, or good and evil, so to say. So whatever you expose the virus or particles or whatever you have in the room to, you also expose to the people in the room. But of course, these type of ionization and other techniques have shown to cluster and reduce particle numbers.
Good, thank you. Okay, we have another question. Feel free to take it and answer it if you feel for it. It goes, concerning the risk of airborne virus, is turbulent air okay when spreading COVID when using air cleaners or not?
Well, I'll raise my hand on that one. It's been discussion even on level of countries. I've seen information from Norway that they do not recommend any kind of air cleaning or movement of the air inside a room. As we said before, this is a reduction of the number of particles in the room, and some of these particles can be virus. And science still doesn't know how many viruses do you need to get sick. Depends on how strong you are, how strong the virus is. But normally, I would say, and we've been talking with Niklas before quite a lot. And the idea with air cleaning is that not that you dilute, but you reduce the concentration. And remember that these viruses, they are airborne for hours. And it's when they concentrate where you have a lot of them and you are exposed to a long time. We had some very interesting findings in the beginning of the pandemic from different places, especially in Asia. We had a restaurant where they could follow the spread, and we had an office where they could follow the spread in the room. And it's very, very clear that with no air cleaning, low ventilation, it's spread very close to where you are, a couple of meters or some extra meters. So to reduce the spread, either you open the windows as much as you can, creating a draft in the room, or you use air cleaners. This is two ways, and ventilation on maximum. But it has shown that it's very difficult to change ventilation or to increase ventilation. You can tweak it a little bit because it's designed and really difficult to change on a fast way.
Great, thank you. We'll try to wrap it up now. Thank you for the questions. Those questions that we don't have time to answer, we will collect the answers and send it out afterwards. I will give you the word soon, Niklas, but first of all, we just have a short question here talking about the virus and for how long time it can live. Do you know from your area for how long can the coronavirus live, and is it possible that it even can grow in ventilation system?
So the last question is easy to address and answer. The viruses do not grow outside a living organism, so it cannot grow and multiply within a filter or within a ventilation or on the surface, for example, or on food, such as bacteria can. So that is a main difference, and we usually don't define viruses as alive or dead or something like that. We talk about that in that way now because it's easy to relate to it, but otherwise we talk about them as active or inactive. That's something to relate to. And when it comes to how long time they can be active then on a surface, that varies between different types of viruses and depending on the humidity, for example, depending on the temperature. It depends on if there is ultraviolet radiation from the sun. It depends on how many viruses that ends up on the surface. The more viruses, the longer time there is a risk for some viruses to be active. But when it comes to the coronaviruses, they are relatively stable to be so-called envelope viruses. So they can, if there are many enough, survive or be active on the surface for many, many hours. We still don't think that contact transmission is very important. That has been shown in several reports now from CDC, for example, from US. So the main mechanism of transmission is through droplets and or through airborne transmission, or both of them. I hope that answers the question.
That was a very good question. Thank you. And thank you for all the questions and answers. Just want to hear last words from the panelists. Niklas, what will you focus on going forward? Super quick, and
Yeah,
then we
thank you.
go on.
First of all, thank you then just for allowing me to be part of this exciting event. And I would like to thank QleanAir for inviting me. I would just like to say a few words about the Pandemifonden, the pandemic foundation created by the Swedish Society for Virology, where the aim is to do more and better research on virology so that we can get the tools that are needed for society, humans, healthcare. We need more knowledge. We need definitely more antiviral drugs. We need more vaccines. And we need to work together in many different ways. So if you would like to support the Pandemifonden, contact me or Sarah or anyone on this event here. And we can work out some good solutions. Thank you.
Thank you. And Håkan and Johan, if you want to work on your indoor air quality and need help, what is the next step? Just to summarize, remind everyone again.
Yeah, you need to, if I start, to be in places with good ventilation. And good ventilation could be air cleaner, could be open windows, whatever. And it's not over yet. Niklas says we don't know yet, and it's definitely not over. So don't let the guard down. And there is an increased awareness of air quality, not only that air quality can be dirty or good, but now it can also be evil. It can be really, really dangerous, and you can catch things as SARS-CoV-19 from just being inside somewhere. So really take care, people, and make sure you're in ventilated areas.
Yeah, I agree with Håkan there. Do your risk assessments for your shared spaces and plan long term.
Great. Thank you for today, and we will collect the answers and send it out afterwards, as we said. Great, thanks.